In Chapter 6 in Calc AB, you learned how to find the area under a curve and find the volume of a figure using different methods. While it's continuing as a part of Chapter 6, what we're going to be looking at in Calc BC is arc length and area of a surface. So at the end of this lesson, you'll be able to find the arc length of a curve, and you'll also be able to find the area of a surface of revolution. All right, let's start with the arc length. An arc length would just be basically a length of something. Let me just go ahead and give an example. Let's say I had a curve that looks something like that, and I would like to find the length of that curve from this x value to this x value. Well, we can definitely find that using calculus. The way that we're going to do that, you'll notice if you look at my arc length formula right here, it's going to be the integral from a to b, so some x value to another x value, of the square root of 1 plus the derivative of the function squared dx. All right, and that would be if it is an equation that's given in the form of y equals. If you have a formula that's given in the form of x equals, you'll notice the formula looks exactly the same. The only difference are c and d will be y values, and we'll take the derivative with respect to y instead of with respect to x. But you'll notice when we work through these problems, they pretty much look the same. All right, so starting with example 1, it says to find the arc length of y equals x to the 3/2 minus 1 over the interval 0 to 4. Okay, if we were to draw that, I believe that this function is going to look something like that, and we would like to find the arc length from 0 to 4. So 0, 1, 2, 3, 4. I don't think that's going to hit at 1, but so we're going to find the length of that arc right there. Okay, to do that, we are going to use the formula, little s equals the integral from a to b, well, we're going from 0 to 4, square root of 1 plus the derivative, so I'm just going to come over here and do a little side trip. The derivative of x to the 3/2 would be 3/2 x to the 1/2, and so that's what we're going to put in here. We'll have 3/2 x to the 1/2, and then we'll square it. And then, of course, that's with respect to x, so dx. All right. At this point in time, you could go ahead and use Math 9 on your calculator to simplify. I'm going to go ahead and simplify this just a little bit more because on a multiple choice section, it might just ask you for a setup. So I want to make sure we know how to simplify it a little bit. So this is going to go from 0 to 4. We'll have 1 plus 3/2 squared will be 9/4. And then x to the 1/2, if I square it, will just be x dx. So either one of those formulas we could go ahead and enter into our Math 9, and when we do that we should get 9.073 as our answer. Okay, question 2, it says use the integration capabilities of your calculator to find the arc length of x equals cosine y over the interval from negative pi over 2 to pi over 2, and notice everything is in the y direction, and this is solved for x. So our formula is not going to change at all. What we are going to do on this one, again, since it's asking us for the arc length, we do want to do the integral setup, so we'll have s equals, my y values that the arc length will go in between will be negative pi over 2 and pi over 2, and then we will do the square root of 1 plus, let me go over here and do a side trip. If x equals cosine y, x prime will equal negative sine y. And so that's what's going to go in here. And then dy again instead of dx. And then from here, before I use Math 9, I am going to simplify it just a little bit. So it'll be negative pi over 2 to pi over 2. Square root of 1 plus, when I take a negative and square it, it will just become positive. And this will still stay the sine of y squared. Okay, from here we can use Math 9 on our calculator. We definitely want to make sure that we are in radians when we do this, and when we come up with that arc length, we should get 2.828 as our answer. All right, the next part is the area of a surface of revolution. So basically what we're going to be doing, if you recall on different problems, let me just kind of bring up one. Let's say I have the square root of x, and we revolved this figure about the x-axis. If you recall, remember we ended up with a shape that looked something like that. We end up with a three-dimensional shape, and in chapter 6 and 8b we were finding the volume of that figure. Well, what we're going to be finding right now is actually just the area of the surface. So like if I wanted to wrap that figure, that would find how much wrapping I would need around it, or like the coating or membrane or whatever it is. Okay, so the formula that we're going to use is s equals 2 pi, the integral from a to b of r of x, which is a radius, and then the square root of 1 plus f prime of x squared dx. So notice the two different parts of this formula from the arc length one, where we've got r of x in here and we've got 2 pi, excuse me. Okay, r of x, notice, is the distance between the graph of f and the axis of revolution. Okay, and you will notice if I'm revolving about a horizontal axis, so if I'm revolving about the x-axis, my radius is going to be dependent just on the x-axis, so it's just going to be, it's going to be dependent on where my function is hitting the curve. So my r of x will equal f of x, right? If I'm revolving about a vertical axis, my r of x will simply just be the x value. Okay, so just keep that in mind as we're doing the next couple of problems. Okay, problem 6, or actually it's problem 3. Set up and evaluate the definite integral for the area of the surface generated by revolving y equals x cubed about the x-axis on the interval 0 to 1. Okay, if I have y equals x cubed, if you remember y equals x cubed looks like this. We're just going from 0 to 1, so it's just this figure right here. We're going to revolve it about the x-axis. So if I do that, I'll get a shape that looks something like that. So remember, we're revolving about the x-axis, and this time instead of getting the volume, I just want the area of that surface. I want the outside surface area. Okay, to do that, we're going to get surface area equals, that's a little s and an integral sign, 2 pi is going to be the integral from 0 to 1. R of x this time, since the x-axis is a horizontal axis, we are going to use f of x, or the y value for this, so we'll get x cubed. And then square root 1 plus my derivative. Well, let me do a little side trip here. Remember, the derivative of this one would be 3x squared. So I'll have 3x squared squared dx. And again, I'm going to simplify this just a little bit. So I'll have 0 to 1 of x cubed. Square root 1 plus 3 squared is 9. X squared squared is x to the 4, and I will ask you to do that because, again, if you have a multiple choice problem, which this would be a common multiple choice problem, they wouldn't ask for the answer, they would just ask for the setup, and you need to make sure that you squared the 3 and the x. Okay, from here you definitely may use Math 9 to get your answer, and when you do that you should get 3.563. All right, let's try one more, and this is actually just example 4. Set up and evaluate the definite integral for the area of the surface generated by revolving f of x equals x squared about the y-axis this time on the interval 0 to square root of 2. So again, f of x equals x squared is going to look like this, and we're going to go from 0 to square root of 2, which is going to be this little part right here. We're going to this time revolve about the y-axis. So if I revolve about the y-axis, I'm going to get a figure that looks like this. Something like that. And again, we would just like to find the surface area instead of the volume. So to find the surface area, we'll do s equals 2 pi. My integral is going to go from 0 to square root of 2. Okay, my r of x this time, since I'm going about a vertical axis of revolution, is just going to be x. And then square root 1 plus the derivative. Well, let me just do a little side trip here again. If f equals x squared, then f prime will equal 2x. So I'll have 2x squared dx, and then let me just clean this up just a little bit. I'll have 2 pi 0 to square root of 2 x, and then the square root of 1 plus 2 squared is 4, x squared is x squared, and now we're set to use Math 9 on this problem. Again, I will be looking for that integral setup. I will also be looking for a picture just so that I know you can visualize what you are finding when you do it. And then if we use Math 9, we should get 13.614 as our answer. So hopefully now you can find the arc length of a curve, and you can also find the surface area of a solid revolution.